Hello everyone, my name is Ajay Kumar Eklare and I welcome you to my video for the project which is based on loan distribution prediction. So today I will explain you about the implementation part of this project. So before I move ahead, I would like to mention my team members, and they are Aniket, Akansha and Bharat, and we all are the students of second year IT department from GHRIT College, Pune. And also, I would like to mention our team mentor who gradually guided us throughout the project, Mr. Himanshu Deshmukh. So let's get started. So the first thing that I've done is I have imported the library. The first library is the NumPy. So NumPy is a numerical Python. It provides fast mathematical computation on array and matrices. So it is an essential part of machine learning. The next library is the pandas. So similar to NumPy, pandas is also one of the most widely used Python library in data science, which provides high performance, easy to use structure and data analysis tools. It also provides in-memory 2D table called DataFrame. The next library I have used is matplotlib. It is a 2D plotting library which is used for creating 2D graphs and plots. Then I have used Seaborn library. The Seaborn library is used to ease the challenging task of data visualization, and it's based on matplotlib. It allows you to create a statistical graphics through its functionalities. And then I have And the next thing I have done is I have imported the dataset. As you can see over here, I have provided the path and my dataset name is train.csv. Then I have displayed the first 10 elements with the help of the head function and passing the parameter as 10. Then I have used the df.describe function. It describes your entire dataset. As you can see over here, it provides you the information like count, mean deviation, standard deviation and so on. Then I've used the df.info function. Now df.info is a function which provides you the entire information related to your dataset. It gives me the name of all the columns, it gives me the data type of the column, and also it provides the count of the non-null values that are present in my columns. Then I've used the df.shape, which gives me the total number of rows and columns that are present in my dataset. So in my dataset I have 614 rows and 13 columns. And next thing I've used is df.isNull.any. This function is used for checking the existence of null values in each column. For example, in loan ID, as you can see, it says false. So false means that there are no null values, but if it is true, then there are null values. So as you can see, there are so many columns which are true. Then we have df.isNull.sum. Now this is a function which helps me to check the number of null values that are present in each column. For example, I have 0 in loan ID and 13 in gender, 3 in married and so on. Now this is another method for checking the information for a particular column. Then we have the unique function. Now unique is a function which helps you to check the unique type of outcomes that are present in your column. For example, in property area column, as you can see, we have 3 types of outcomes only, which is urban, rural and semi-urban. Then I have used the value count function. Now this is a function which helps you to count the number of occurrence of each outcome in a column. As you can see over here, semi-urban has occurred 233 times, urban has occurred 202 times and rural has occurred 179 times in the property area column. Then I've used the df.drop in a function. Now this is a function which is used to clean your dataset by removing all the null values. It removes the null values by removing the entire row which has a null value. So as you can see, we had 614 entries, but now we have 480 entries, which means all the null values are removed by removing the entire row. But the disadvantage is that there is a huge data loss in this. Moving ahead, we have the data pre-processing. Now data pre-processing is a step of machine learning where we clean the entire data set for the model to easily interpret with the algorithm. First thing that I've done is I've replaced all the null values by the digit 1 in the dependence column. So as you can see over here, dependence column has 599 non-null values. So after replacing it by 1, now there are 614 non-null values. The next thing that I've done is I've used the mean function. Now mean is a mathematical function. Now what I have done is in loan amount column there are 592 non-null values. So I have taken the mean of all these 592 null values and then I have stored it in the place of the vacant spaces of this column. So as you can see over here, now I have 614 non-null values. That is, there are no null values present in this column anymore. The next thing that I've done is I've used the mapping function. The mapping is a function which is used to convert the character data type into a numerical data type because the machine doesn't understand the character form. So what I've done is in the married column, I've assigned 1 for yes and 0 for no, and I've stored the numerical values inside another column named as married section. And as you can see over here, the married section is now appended in your dataset. And I've done the same for other columns as well. The next thing that I've done is I've used the label encoder method. Now label encoder method is another way for converting the character data type into a numerical data type. Then we come here at the data representation. So the first data representation is the scatter representation. As you can see over here, there is loan status in x-axis and loan amount in y-axis, and I have represented it in terms of the general section. Now this is under scatter plotting, where I have applicant income in x-axis and co-applicant income in y-axis, and I have represented it in terms of property section. This is a histogram representation where x-axis represents the loan figures, y-axis represents the count, and this diagram is the loan taken by the customer. This is the box plot representation. This is another histogram representation, and this is called K plot representation. Then I have used the correlation matrix. So correlation matrix is used for feature selection. In other words, we can also say that it is an indication about the changes between the variables. From the above output of correlation matrix, we can say that it is symmetrical, that is, the bottom left is same as the top right. So we can say that each variable is positively correlated with each other. Now we have used the algorithm implementation. Now algorithm implementation is used for training and testing the model. So the first algorithm that I've used is the logistic regression. So I've imported some more libraries and classes. Now all the inputs I have stored is in the x variable, and the output that I have stored is in y variable. Then I have divided my dataset into two parts in 7:3 ratio, where 70% of the dataset will be used for the training purpose and the 30% of dataset will be used for the testing purpose. Then I have trained the model by using the model.fit function. As you can see over here, 0.80 is my training accuracy and 0.83 is my testing accuracy. And similarly, we have done the support vector machine which has the different accuracy for the training and testing. Then we have used a random forest which also has the different accuracy rate, and at last we have used the decision tree. Now these were the 4 algorithms that we have implemented in our program. So that's it, and thank you for watching our video.